Okay, this is our last section of notes for Unit 1. Yay! Let me bring it up for you. Okay, so we're still in Unit 1, but this is Section 4. I'm going to get into a little bit of the chemistry stuff, specific chemistry stuff that, makes, when you think chemistry, this is what you think of. Okay, so basically chemistry, we're really just going to be studying matter and energy and how the two basically interact with one another, change the two. Think about everything is made up of chemicals, including you, plants, the air, stars, pretty much everything. And there's just some pictures showing you, different aspects of chemistry, looking at, solar composition versus chemistry of the body and chemistry of our atmosphere. So what is a chemical? It's a substance that is produced or used in a process, which we call reactions, involving changes to the atoms or the molecules. If a chemical composition changes, it's called a chemical reaction. So if you take one thing and you turn it into something else, that's definitely a chemical reaction. And many of those chemical reactions are reversible. If you've had my anatomy class, we've actually talked about reversible reactions in there. We have something called the law of definite proportion, which means any given chemical compound always contains its component elements in a fixed ratio. For example, water will always be 2 hydrogens and 1 oxygen, H2O. One molecule of glucose will always be, 6 carbons. H would be 12 hydrogens and then 6 oxygen, C6H12O6. So glucose will always have that fixed ratio. So what are phases of matter? This is pretty easy. You guys know this, definitely done this since kindergarten probably. The phase of a substance is represented by how attracted its atoms are to one another. So solids, those, atoms are very attracted to one another. They're very close together. There's a very strong attraction, and it has a fixed volume and shape. So, ice, or, it's going to have its fixed shape. It's not going to change. Liquid, however, atoms are still kind of close together, but the attraction is not as strong as with a solid. And there's a pretty, fixed volume there. Volume's not going to change, but it is more, I should say, liquidy or fluid. And then gases, on the other hand, the atoms are far apart. There's no attraction, and they'll bounce all over the place. And if you open the container they're in, they'll just, diffuse out into the atmosphere. They can be easily compressed, those. They can be easily pushed together. But we'll talk about gases in that unit. We won't get too much into that right now. So what is matter? Any substance with mass, volume, and inertia. It includes everything you see around you except light. The volume is how much space an object occupies, and the mass is the amount of a substance. We talked about how to do the water displacement to get volume in the other section of Unit 1. And here's a scale, digital scale. We used a triple beam balance in one of the examples, but you can throw it on a digital scale and it'll tell you exactly, more precisely, the mass. All right, when we classify matter, we kind of throw it into different categories. So we start off, of course, with the atom, which is the smallest, piece of matter, kind of like cells and living things. Atoms are for, chemistry. There are about 110 different known kinds of atoms at this point. So we're always discovering new things. Atoms, elements, compounds, and molecules. Atoms are incredibly small. Tiny. Like you can't see it with a microscope, tiny. And you can see all those zeros there, which is basically the diameter, 5.64 times 10 to the negative 16th meters. Which is why we use scientific notation. There's an example of 20,000 zeros we'd have to write across the screen, which is a lot easier to write 5.64 times 10 to the negative 16 than to write all those zeros. So you have elements. Elements are pure substances that are made up of the same type of atom, and elements are given an atomic symbol that consists of a capital letter And then sometimes it has a second letter that would be lowercase. For example, oxygen symbol is capital O. Aluminum would be capital A, lowercase l. Gold, capital A, lowercase u. So anyway, those are the symbols you see on the periodic table. Compounds are groups of elements bound together chemically. You'll get a subscript, as seen right here with sucrose. It tells you how many of those atoms are in, a compound of the element. So table salt, for example, would be sodium and chlorine bound together. Since there's no subscript there for either one of those, that denotes that there's one of each. And in sucrose, you'll see we have C12H22O11. So that means in every molecule of sucrose, you have 12 carbon atoms, 22 hydrogen atoms, and 11 oxygen atoms. All right, atoms, elements, compounds, and molecules. Continuing on, a pure substance is just made out of one type of element or one type of compound. And it's identified by its unique chemical and physical properties. We'll talk about chemical and physical properties in Unit 2, but here we have oxygen. Usually it is in our atmosphere, bound together with another oxygen. This denotes a double bond. We'll talk about that later, but basically you have two atoms of oxygen, and this is how it is normally arranged when it is floating around in the air, O2. And that's a pure substance because it's only made out of oxygen. Molecules, on the other hand, they're compounds. They don't necessarily have to be different elements. They can be as few as one atom. Monatomic elements like helium, just one atom. Mono means one. So one atom of helium. Diatomic, di meaning two. So just to give you some examples, bromine, again, it's kind of like the oxygen thing where they like to hang out together. So you get two atoms of bromine. Iodine, this would be a diatomic, two of those together, so on and so forth. Other common molecules that we'll talk about a lot is carbon dioxide, CO2, and water, of course, H2O. Okay, the periodic table. We'll definitely be doing a lot of talking about the periodic table. I just wanted to give you a few small items right now, and we'll talk more about it later. But your periodic table arranges all the known chemical elements from left to right, top to bottom, in order of increasing number, atomic number. Okay, so we'll talk more about that too. This order coincides with its increasing atomic mass. As long as it's a stable atom, but definitely the number of protons. And the atomic mass is where they add together the protons and the neutrons together, so it's the bigger number. The rows going across the periodic table are called periods, and coming down each column, they're called groups or families. And the elements are organized by families that have similar properties. Okay, you have three main categories for the groups or families. The metals, those are groups from 1 to about 13-ish. And of course, metals are shiny, they conduct energy, they're usually solids at room temperature. Non-metals are the groups between 14-ish and 18. You kind of have that little section that's kind of like merging together, so that's why I put the ish there, but we'll come back to that in more detail. So non-metals, they're dull, they're insulators, they're usually gases. And then you have the metalloids, also called the transition metals, and they separate the metals from the non-metals. They're also shiny, insulators, and usually solids. So when you're looking at the periodic table, group 1 are your alkaline metals. They explode in water, so sodium's on that list. We don't want to get sodium wet. Group 2 are the alkaline earth metals. Group 3 through 13 are your transition metals. Group 16 we call the chalcogens. That's the oxygen group. Halogens is group 17. They're extremely reactive. And then in group 18 are your noble gases. They're inert. They don't really react too well with anything. They're pretty happy the way they are. And I just created a periodic table that kind of shows you when the alkaline metals, alkaline earth metals, transition metals are here in the middle. Here's some other transition metals down here that they kind of have to squeeze in. And then you have your nonmetals over here. There's your halogens there. That's the fluorine, chlorine, bromine. You have the chalcogens, that's your oxygen, sulfur, and all that going down. And then your noble gases over here, helium, neon, krypton, xenon, stuff like that. Okay, and then we have this little group here called the metalloids. But again, we will come back and definitely get into more detail on the periodic table in our next unit. But for now, that's all of Unit 1, which is plenty, I know. Hopefully the math stuff you already kind of knew ahead of time, so hopefully there won't be too much studying there. But please let me know if you have any questions about Unit 1, Section 4. Okay.